This video is about the E2 reaction mechanism and involves the anti-periplanar transition state. The reagent, in addition to the alkyl halide, is ethoxide. The alkyl halide, as you notice, is a secondary alkyl halide, and the ethoxide is a strong base. So this reaction is going to go by an E2 mechanism, which means the geometry of the transition state will be anti-periplanar. We're going to pretend to be a bug sitting on the screen looking at the reacting molecule from the edge of the carbon with the chlorine attached. In order to make it easier to draw this Newman projection, we're going to use the abbreviation pH to stand for the phenyl ring that's on the right part of the structure. And that is on the front carbon, and the phenyl ring is pointed up. And we're going to use the abbreviation ET to stand for the ethyl group that is attached to the back carbon and pointed down. Now I have added the methyl group and the hydrogen, so I have a complete Newman projection. One issue with the Newman projection is it doesn't have the hydrogen that's leaving and the chlorine that's leaving anti-periplanar to each other. I have redrawn the Newman projection by rotating both the front and the back carbons, putting the chlorine pointing down and the hydrogen pointing up. That helps us see what groups are going to line up with each other as the bonds form and break in the transition state. So the next structure is the transition state. You can see the carbon-chlorine bond is breaking, the carbon-hydrogen bond is breaking, the bond between the strong base and the hydrogen is forming. What we can't see from this perspective is the forming carbon-carbon double bond, but we get a sense of that because the geometry of the two carbons involved, both of them are flattening out. So the phenyl on the front carbon is moving down, and the ethyl on the back carbon is moving up. They're getting closer to each other. So when we see the alkene at the end, the phenyl and the ethyl are both on the same side of the double bond on the left, and the methyl and the hydrogen are both on the same side of the double bond on the right.